This problem is about building towers in a coordinate line, where each tower has a specified height. The goal is to find a configuration of towers that is considered beautiful and maximize the sum of their heights. To be beautiful, the configuration must meet two conditions. The heights of the towers must form a mountain shape, meaning there's a peak in the middle, and the heights increase on one side of the peak and decrease on the other side. The height of each tower must not exceed a certain maximum height specified in the array max heights. The answer provided suggests a solution using a stack data structure to find the maximum possible sum of heights for a beautiful configuration. Here's a verbal explanation of the solution. Initialize an empty stack to keep track of the indices of the towers forming the increasing sequence of heights. Start iterating through the array max heights from the beginning to the end. For each tower at position I, assume that it is the highest tower. We want to build a beautiful configuration with this tower. While iterating, we check if there are any towers in the stack previously processed towers that are taller than the current tower at position I. If we find taller towers, we pop them from the stack, update the sum of heights ker, and push the current tower's index I into the stack. After processing all towers from left to right, we've created a beautiful configuration with the current tower as the highest tower. Next, we reverse the process by iterating through the array max heights from the end to the beginning. Again, we assume that the tower at position I is the highest, and repeat the same process to create a beautiful configuration, but this time, it starts with the tower at the other end. Now, we have two beautiful configurations, one with the current tower as the highest tower on the left side and one on the right side. We sum up the heights from both sides and keep track of the maximum sum achieved for any tower as the highest. Finally, return the maximum sum of heights, which represents the maximum possible sum of heights for a beautiful tower configuration. In essence, the solution explores different tower configurations with each tower considered as the peak of the mountain, and it aims to find the one that maximizes the total height while adhering to the mountain shape and the height constraints specified in max heights.